So looking at this here, finding a line of fit, there are several steps that we go through. The first is to create a scatter plot of the data points. We want to plot all the points that are given to us that we're trying to find the line for. 2, sketch a line that most closely appears to follow the trend given by the data. So kind of in the middle of all the points that kind of best represents everything. Choose 2 points on the line, estimating the coordinates of each point. These points do not have to be the original data points. And then write an equation of the line that passes through the points, 2 points, from step 3. This equation is a model for the data. And this is one of the reasons we won't have a specific assignment on it, because it's, again, sketch a line that most closely appears to follow the trend. Well, my line is going to be different than any of y'all's lines, because again, it's going to be where we think it best models it. So it's hard to give a solid, this is the line. Now, there is an actual more mathematical approach to it, because we don't just pick a line that actually best follows it. There is a mathematical approach to figuring out. We look at the distances between the points and how they relate to each other, and going on from there that this does. Now, they set this up here with this. I'm going to and I'm going to grab a note sheet. And we could go through doing this with this problem, but I'm not going to worry about it. You don't have to write this down. This is straight from the book. The line of best fit is the line that lies as close as possible to all of the data points. Many technology tools have a linear regression features that you can find in the line of best fit for a set of data. So it will calculate the line of best fit for us. Now, the correlation coefficient, denoted by R, is a number from -1 to 1. That measures how well a line fits the set of data. When R is near 1, the point lies close to a line with a positive slope. When R is near -1, the points lie close to a line with a negative slope. We want 1 or -1. We want it to be as close as possible to one of those two. The closer that it is, the better the fit. So just because it's close to -1 doesn't mean anything. It just means the line's going down. If it's close to 1, it just means the line's going up. We want it to be one or the other. If it is close to 0, if R is near 0, the points do not lie close to any line. There is no line that will well define the data. It just doesn't work. So we really want it between or close to -1 or 1. The best ones are within 0.05. So we're talking about 0.95 or -0.95 are going to be great fits for the data if they're at that point or better. Now, well, I'm going to draw a line apparently. We're going to go through this. So the steps are all listed out here. I do have them in your note sheets. But let's grab the graphing calculator. Now the first thing we want to do, because we have femur length and overall height, and we want to see, is there a correlation between the average or the person's femur height, femur length, and their overall height? Now we want to use a linear regression to calculate how this would work. Now to do that, the first thing we're going to do is hit stat. So there's an STAT button after you turn it on. So hit it, and we want to hit enter for edit. And you should be given L1, L2. So do y'all have something that looks like this here? That's all blank. Okay. So if it's not blank, if you hit delete, DEL, you could just be at the top one, just hit it. You don't even have to move down. Just keep hitting it and it'll clear everything out. Yep, so we can clear all those out just by hitting delete. Yep, so we can go over. So what we want to do is we want to put the X values in the first one, Y values in the second. So our femur length, according to this here, according to our data, is going to be X. So our first number is 40. So we can say 40 and then hit enter. If I can hit enter. And you see it entered 40 and then dropped down one. So we'll enter them all in. So 45, 32, 50, 37, 41, 30, 34, 47, 45. Yes, so once we get all those in, we're going to do the Y in L2 and make sure, because it should line up. So 40 and 170 should be right next to each other. So So we want them to be next to each other, so 40 and 170, because what we do next for linear regression, it's going to assume first and first are an ordered pair, second and second are an ordered pair. They're going to combine those. So we make sure we kind of line them up this way. Any questions on this here? So we have all that inputted, yes? Go on and hit second, quit, second mode. So we should be back to the home screen. Now we did talk about the R value being close to 1. We have to actually turn that on, because if the calculators get reset or been reset at any point or it hasn't been turned on, it's not going to show up the R value. We have to turn it on. So what we're going to do is we're going to dig into the catalog. So the catalog, you're going to go second, 0. It's in blue. Now, what we want to do is we want to get down to diagnostics on. Well, I can hit the down arrow to go down to diagnostics. But if you notice up in the top corner how it has the A, because again, when it's blue, because you see whenever you hit shift, it normally pops up an up arrow, kind of letting you know shift's active. This is letting us know that all the green keys are on. That if we hit one of the buttons, the green key would be used. But what does diagnostic start with? So make sure this button here is D. If I hit it, it pulls it all the way down to D, so I don't have to go as far. And now we just need to scroll down to diagnostic on. I went way too far. Hold on, let's go back up. Diagnostics on. Once you get there, hit enter. Enter. So there's diagnostic off and then diagnostics on. Yep, so hit enter on diagnostic on and then hit enter again and it should say done. Quit. Second catalog D. Diagnostic on, enter, enter. So we got this reading on your screen, diagnostic on, done. Okay, so that'll give us an R value. Okay, now the next part's actually dealing with the numbers. So if on a test you forget about the diagnostics, that's fine. It just won't give you an R value. It will give you everything else. We're going back to stat. And again, we want to actually have a linear regression. We want to know what the line of best fit is. And so we want to, well, calculate that, yes? Well, if I go over one at CALC, calculate. You notice the fourth one down, REG, linear regression. AX plus B, equation of a line. Y'all see that there? Go on and hit enter to select it, if I can find it. Now, if you notice this here, it says X1, X list is L1. Yes, that's where we put the X values, yes? So I can hit enter. Well, L2 was the Y list, yes? So we can hit enter. We really don't care about the frequency. Now, store regression equation. So if we wanted to see this graphed where we didn't have to type anything in, we can do this. Now, for this here, let's do that. Let's do alpha, so the green button, and then F or trace. Alpha, F4. Alpha, trace. Alpha, trace. So we got this list here. Now, Y1 is the graph, because if we want to graph a function, Y1 is where it would graph. Yeah. If you don't hit alpha first, it will send you over there. So alpha, F4. So Y1 is when we graph, and we will, we'll put the first equation in Y1, the second in Y2 going down. So let's just hit enter and tell it, put it in Y1. Put the equation in Y1. So we have this here. Any question? So stat regression clear. F4. Second stat. Yes. Regression, second. Okay. So down here we'll do alpha F4. Enter. Okay, so you can go on and hit enter. Yep. So we have it look like this. Go on and hit enter. If I can hit enter. And it should have you down on calculate. Go on and hit enter again. Tell it to calculate it. So it gave us this here. And again, when I talked about this yesterday, I said that, yeah, I was hitting all around the enter button. When I talked about this yesterday and I said the numbers aren't nice, this is what I mean. Because this is telling us that the slope, A, is 2.603570555, this number here. The y-intercept, where it intercepts the y-axis at 64.99682074. But it does tell us the r value is 0.9945. Could we say that this closely represents the data? Well, yes, because if it does, it's either close to 1 or -1. If it's close to one of those two, it is good data. And if it's above 0.95 or below -0.95, between -0.95 and -1, or 0.95 and 1, it is really good data. It's a really good fit. So here, this is really close. So let's actually look at what the equation looks like. So if you hit y equals, this is where we'll graph most every line. Well, hey, the equation's already in there, isn't it? That's what happens when we said store it here. And it stored it there for us. We didn't have to type anything in. It already put it there. So, do we have to do this every time? If you were wanting to do line of best fit. Yep, so you'll have to go through that process. Except for the diagnostics, because it's now turned on, we won't have to worry about that again unless it gets reset. Now, I'm going to do this here for y'all so you can see. Enter. Okay. Go on and hit graph. Or just hit graph. And it should give us something like this here. Okay. Just had to clear the other ones out. There, yeah, that's fine. Stat. Let's make sure. 40, 45, 30. Is 45, 32, 50, 37, 41, 30, 34, 47, 45. So y'all have a graph that looks kind of like this here, yes? Okay. Oh yeah, because we have that other equation in there. You're welcome. So this here, well, if we look at the first point, or any of these points, what is, well, the lowest y value doesn't break 100, does it? This here, or most of them, are set up on a 10 to 10. Negative 10 to 10 on the x, negative 10 to 10 on the y. It does not fit this scale, does it? So it might be helpful if we zoom to make it fit. Zoom. So zoom in is going to zoom this graph in. It'll make it smaller. Zoom out will make it bigger, but it's only going to go by certain intervals. Z decimal will get it into kind of a decimal form, the grid. Z squared is going to give us a square, so it's like negative 10 to 10. Z standard is our negative 10 to 10 on both. And normally if it's way off to one side or whatnot, you can go zoom 6 and it'll center you back up. Trigonometry, integers, zoom statistics, so if we're looking at stats. But none of these are what we want. Zoom fit. Zoom fit is going to say, hey, it's going to tell the calculator, I want you to set the x and y values, or the way the grid's set up, so that it fits all the data. And hit enter. Tell it zoom fit. So it reset it so that we could see this here. Yes. So we'd have this here. Now we can actually mess with the window itself. So I'll show you this here. So window, I can set the scale of how I want the numbers to look. Now, our smallest x value is at 30, yes? Because on the height of the femur? Because it'll depend on how you scaled it, or how the calculator scaled it for us. Yeah, so we can change these. There's nothing that's restricting these. Because we could say, I'm going to go, the lowest value is going to be 25. y'all can just watch this here. It's not hugely important because we won't delve into this too much. Because most likely the calculator can do this for us. Now the biggest value was at 50. So I'll say 55. Enter. So the distance between those is 30. So I'm going to set my scale to 3. I did 3 because, again, it would be 10 increments of 3 to get from 25 to 55. So we get a nice little scale. Now, looking at the height of the femurs, well, the smallest one is at 151, so I'll set it below that at 150. And the biggest one was 185. 41. Okay, that'll be important. So I'll set it 140 to 190. With a scale of 5. Because distance of 50 divided by 10, 5, so I can have 10 nice bars. Nope. So we'll need 200. Thank you. Keep me on my toes. Too far. So we can say that this is, just go, 200. 200, that would be 60, so we'll just reset the scale at 6. So the line's pretty close to all those points. Yeah. Now, so if you typed all that in, did you get the line? At least the line, not the points, just the line? No? Alpha trace. Yep, because it lost it.
What do I do now? Press what?
Well, so we went
Oh, was that supposed to be
140. Yeah, no, you didn't have to.
Oh.
If you did change them, then it would change how it looked. But because if you didn't change it, it won't change anything. So what I changed was the X and Y coordinates so that it fit the data.
Oh, okay.
So I did it manually because, as we noticed there, the stat plot didn't quite give us a good enough window for it. And we get this here. Now, the points themselves, is unless you change the window to be this, won't show up, even if we do this next step. But if you click on Y equals, so you can do this here. So hit Y equals where you pulled the graphs up. If you notice my plot 1 at the top, y'all see it says plot 1, plot 2, plot 3?
Yeah.
You notice how it's darkened?
No.
Mine is darkened, y'all's is not. If you, yep.
Wait, which one?
So plot 1, do you see how it just says plot 1? Where mine has a black box, and because yours is black lettering, mine's white lettering. I have it turned on. And what that does is it takes the points from L1 and L2 and graphs those ordered pairs.
Oh.
So turning that on will graph those ordered pairs, which means on this here, I get these points. So that's how it graphed those points. Yep, because the window that it's set is, those points are outside of it. It doesn't like it. It won't graph it there. Yeah. But this here is not something that we're going to utilize too much at all. I'm not going to have you test you over this or test the line of best fit because there is a ton of process in doing this. But how much of it actually required you knowing the mathematics behind this? Well, none. It's just you plugged it into the calculator and that was it. So if I did test you over this, it's not testing you over being able to do the line of best fit, is how well can you plug something in. So we're not worried about this. So let's move on to the next part, the last part that we're going to do, okay? So you ready for the next part? So we're going to go second plus 7, 1, 2. So you should get something like this here. Yes? Second plus 7, 1, 2. Second plus 7, 1, 2. Huh? Second, what? Plus? No. Second. Plus 7, 1, 2. Okay. Whenever we do that, you don't have to do that. You don't, because these calculators get put back and then the next class comes in. So what we did is we just cleared everything out. So you don't have to do these next set of steps because I'll just show you. Because if we go now into stat and enter, L1 and L2 are blank. They're cleared out. Y1, it's cleared out. Everything's cleared out. So I did that so that when the next class comes in, they can actually, we can go through this together with them. But that's it for that there. Now, I'm going to, so we're not typing anything else in. Stat. Now, if you notice here, we have quad, cubic, and quart REG. We can do more. Because a quadratic is talking about a U-shaped regression. Or a cubic is a cubic function or quartic. We can do those there. So that's going to be the